So imagine a balloon at time t equals 0. After, I don't know, 10 seconds, we blow air in it. It looks like this. And then after 20 seconds, it looks like this. So we pump air in this balloon. What changes? From here, here, here. What changed? Or what changes when we blow air into a balloon and we get into different stages? What do you think?
The size?
Yes, so you mean the volume. Good. What else?
The radius?
Excellent. What else? You can say the diameter, but this is 2 times radius, right? What else? Right? The surface. So the surface area is surface area. The surface area is here, much smaller than here, and which is smaller than here. Okay, all these, what am I doing? All these are functions of now. They were not. If I have the balloon right here, deflated, nothing changes. The radius doesn't change, the surface doesn't change, the volume doesn't change. But as long as I pump air into the balloon, these three change. All of them, the volume, the radius, the surface area. They all just became functions of what?
Time.
Of course, they're all functions of time. The volume is now a function of time. It changes with time. The radius is a function of time. The surface area is a function of time. They all became functions of time. Okay, so here is an example of an equation when it comes to assuming that this is a sphere. It can be some other shape, but assuming it's a sphere. Well, the volume of the sphere is 4 pi over 3 r cubed. As you see, there is a relationship between the volume and the radius. Okay, now this is a function of time now, and this is a function of time. And if I want to find the rate of change of these two and the relationship, so the rates of change of V and R are related. When this goes up with certain, of course, certain other correspondence, but they are related. They happen at the same time. Okay, so if I want to differentiate, I will have dV over dt equals, I bring 3 in down and simplify, 4 pi r to 3 minus 1 times dr over dt. So as you see, this rate of change of volume with respect to time is related through this equation to the rate of change of radius with respect to time. They are related. How come? They are in this equation, related by this equation. This is the idea of related rates. And now let's look at problems. Let's start simple and then move on to word problems. Any questions before we do that? Anyone would like to ask any question? Any question? Okay, so I'd like to start then with number 9 on page 364. Okay. We are given y equals e raised to 2x plus 1. They're asking us to find dy over dt when x is 4 and dx over dt is 0.5. Okay, so first of all, let's analyze not the function, but let's analyze what this is. It clearly tells me that the function y is a function of time, like here. Very clear that the volume is a function of time. Otherwise, how will I differentiate if t is not there inside v? So dy over dt means that y is a function of time. We're asked to find this, not only, but evaluate it when x is 4 and when dx over dt is 0.5. But what does this mean? This also tells me what? Can anyone explain what this is telling us?
Maybe we have to compare the difference between the two.
No, what does this mean? So let me start from scratch. So if I'm asked to find dy over dt, it specifically means, listen, find the derivative, but that means that y is a function of time. After you finish this, given that, knowing that, evaluate this when x is 4 and when dx over dt is 0.5. This is given to us, this is given to us. So now let's just look and analyze dx over dt. What does this mean? I'm told dx over dt is whatever. What is the conclusion? That x is what?
A function of t.
Exactly. Thank you very much. Excellent. It is a function of time. Absolutely. Or t, whatever. It may not be time. It may be something else. We don't care. Yes. So then, now I look here and say, you are really telling me that this is a function of time, or t, and this is a function of t. This is crucial to understand. They're not telling us. So here you can say, oh, y is a function of x, I'm done. No. Y is a function of time. And x is a function of time. I keep saying time, function of t, because t may be something else. Okay. Good. So now let's differentiate both sides. The left-hand side, what do I get when I differentiate y?
Dx.
You mean dy over dt. Okay. So now I have e to a function. How do I differentiate e to a function?
The function plus f of x prime.
So we have e to the function, right, which is 2x plus 1, multiplied by the inner function prime. 2 is 2. 1 prime will be 0. But how do I write the derivative of x?
would be dx over dt.
Brilliant, of course. That's why specifically I put this dot under x and y just to refresh our memory or remember that they are both functions of time. Excellent. So now they want us to evaluate, fine, not a problem, when x equals 4 and dx over dt is 0.5. Not a big deal. So I'm going to continue here. 4 times 2 is 8, plus 1 is 9, e to the 9th. 2 times 0.5 is 1, and this is it. Any questions on this problem? Okay, so there are two rates of y with respect to time, rate of change of y with respect to, t, and the rate of change of x with respect to t are related. How come? They are related by this equation. Where does this come from? From this relation in which both are present in this equation. So when I differentiated this equation, I still got a relationship, but this time it was a relationship between the two rates of change, between the two derivatives. That's the idea of related rates of change. Okay, moving on to another problem, unless you have questions for me. Anyone? Anyone, please? Don't be shy. Okay, let's look at another example. Let's also look at 17. We are given that y equals p squared q, and they're asking us to find dq over dt when, so this bar really translates into when p is 15, q is 40, dp over dt equals 55, dy over dt equals 54,750. And this is our question. All this means nothing. I have to find that first. And then I can plug in all this. This doesn't mean anything at this point. Do not touch this. First, we have to find dq over dt. But now we have to analyze what is given. I'm told to find dq over dt. I am also given dp over dt. And I'm also given dy over dt. What does this mean? What does this tell us? This is very important because I don't know how to proceed if I don't analyze what is given to us. So what does this all mean? Anyone? It's okay if you're wrong.
So P is a function of T.
Excellent.
Y is a function of T.
Of course.
And G is a function of T
Yes,
as well.
yes. G, Q, whatever, it doesn't matter. Perfect. Okay. Excellent. So now we have to differentiate both sides. When we differentiate the left-hand side, what do we get?
Would be dy over dt.
That's it. Now I have to be very careful. How do we differentiate this? Which formula or rule we have to use?
Extended power rule.
Okay, but first I have to identify that it's a product. So every time I differentiate a product, I will have to get two terms. First term and second term. Good. So how do we differentiate p squared? Anyone?
Pull the 2 down in front.
Say that again.
Yeah, you pull the 2 down in
Yes,
front.
awesome. Brilliant. Good.
And then it would be PQ. That'd be dP over dt.
dP over dt, awesome, times q, awesome. So when we differentiate a function to a power, we bring down the power, we subtract 1 from the power, times the inner function prime, awesome, times the second one, perfect. So now p squared times, we need to differentiate the second function. What do I write?
dQ over dt.
Again, brilliant. Does everyone understand this? Please ask before we continue. This is what I'm after. This is my variable. I have to solve for it. This moves away, and I divide by p squared. Okay? So 2pq dp over dt moves to the other side. Change its sign. 2pq dp over dt equals p squared times the variable, which is dq over dt. Now we divide both sides by p squared to get our variable by itself. dq over dt, everything over p squared. All this. Do not separate dp over dt. This is 1 unit, this is 1 unit, this is 1 unit. So dy over dt minus 2pq. And it's done. Because now, when p is 15, q is 40, dp over dt is 55, and the last one, dy over dt is 54,750. All I have to do is plug it in.
Did you purposely take
No,
out dP?
no, I was just looking. No, no, no. I just didn't copy it. I was just looking at it. Thank you very much. No, there was no purpose. And no, I'm not hungry. And no, I didn't lose my mind, I hope. No, I just didn't copy it. By mistake, sorry. I wasn't trying to see whether anyone is following. No, it was just a silly mistake on my part. My apologies. Thank you. So dy over dt, 54750 minus 2 times p, 30, times q, times 40, times 55. Of course, I don't have enough room here, so let me, I don't even know why I even tried to put it there. No sense. Thank goodness for whiteout. What will I do without it? I got new bottles. Okay, so sorry about that. Good. So p squared, 15 squared to 25. The top dy, 54750 minus 2. And then p, 30. Let me write it like that. And then q, 40. And then 55. Okay. So I'm going to share my screen. And we go to the calculator. And we're going to punch in these numbers.